This video is going to show the solutions and how to get the answers to the Coulomb's law multiple charge practice sheet. I'm going to start off with number 1. We have the arrangement of charges on your paper, and the first thing I'm going to do is find or draw in the force vectors. So let me start with the pair CB. We're going to work one pair at a time. C is negative, B is positive, so C is going to attract B, and I'm going to label that force C. And let's look at the pair A and B. A is negative, B is positive, so A is going to attract B. And I want to do everything from charge A, or charge B. Everything should be drawn from charge B because that's the charge of focus when you read the problem. And then D and B, the pair, D is positive and B is positive, so D is going to repel B. So we have force D. The next thing I'm going to do is find out what each of these force values are. So let me try to do that work over here. Force A, using Coulomb's law, equals K, Q, let's see, the pair is A and B, so QA, QB, over D squared. K is 9 times 10 to the 9th. Charge A is, I'm leaving out the negative, 2.4 times 10 to the negative 9. And charge B is 1.9 times 10 to the 9th, divided by, now the distance between them is actually 0.13 meters. We have to add these two distances together, and we're going to square that. And we end up getting a value for force A of 2.3 times 10 to the negative 6 newtons. We'll go to work now on force B. And I would recommend that you do the calculation out on your own just to get used to plugging those numbers into your calculator. I think that's an important step. Sorry, I miswrote here. It's not force B. We're actually going to go to work with force, let me do C next. I'll do C, then D. Force C, so it's K, Q, C, Q, B, over D squared. Numbers are 9 times 10 to the 9th. Its charge C is 1.4 times 10 to the negative 9, leaving out the negatives. And B is 1.9 times 10 to the negative 9. Divided by the distance between those two is 0.12 squared. And that value is 2.1375 times 10 negative 6. And our final force value to get is force D. And that's going to be, again, Coulomb's law equation. K, QD times QB over D squared. Plug in the numbers. K is 9 times 10 to the 9th. D is 1.8 times 10 to the negative 9. B is 1.9 times 10 to the negative 9. Divided by the distance between those, very small value, 0.04 squared. And the final value is 1.4175 times 10 to the negative 5 newtons. I forgot I have newtons up here. So those are our three force values. The next thing that I'm going to do is if you notice, there's two forces in the x direction. And what I want to do is just combine those into one x force. So force in the x direction equals Fd, D is the bigger value, look at the number, minus force A. So Fx equals, let's see, 2.1375 times 10. Oh, I mixed that up, I apologize. Let me write the correct number first. 1.4175 times 10 to the negative 5 minus 2.1375 times 10 to the negative 6. So the force in the x direction is, I don't think I prepared that one. Let me do that math out. You can try to do that on your own. I strongly recommend trying to use the EE button. It kind of saves a little time. That value is going to be 1.20375 times 10 to the negative 5 newtons. Now there is a y force, but Fy also just is equal to Fc. So there's really no there. So what we end up getting is a, if I create some more space here, force diagram that's going to kind of look like this. This is F in the y direction, and a force in the x direction. And now I'm going to combine those. I'm using the parallelogram method. You could use, there's F net. You can use the tip to tail method if you want. Remember, Fy is equal to Fc. And now we're going to do the workout to get F net. So I'm going to use the Pythagorean theorem. F net squared equals Fx squared plus Fy squared. Remember, this side of the parallelogram is equal to the side opposite, so they have the same length. Doing the S net out, F net equals the square root of Fx squared plus Fy squared. Numbers are going to go in. Fx is, let's scroll up and take a look, 1.20375 times 10 to the negative 5 squared plus Fy is also Fc, so that's 2.1375 times 10 to the negative 6 squared, and we can get that value, which is, depending upon rounding, you're going to have different answers, but 1.21 times 10 to the negative 5 newtons. We also need to find an angle because force is a vector and it needs a direction. So I'm going to find this angle here, and if I look, this is a right triangle. So we're working with all vectors that are at right angles to one another. So this is the opposite side. Fy is the opposite side to the angle, and Fx is the adjacent side to the angle. So I can use tangent. Tan theta equals Fy over Fx. Theta equals tan inverse Fy over Fx. I'll plug in the numbers here. Theta equals tan inverse of Fy was 2.1375 times 10 to the negative 6 over 1.20375 times 10 to the negative 5. And the angle is, let's just put this all together, the angle is 10.2 degrees, and that was north of east. If you found the other angle, it would have been, let's see, a 79.8 degrees east of north. And we can box that. That was a major mistake. Need the rectangle tool. There you go, right there. It's a nice little official box. And there you have it. There is how you do problem number 1 on the multiple charge practice sheet. So I hope it helped.